Hello class, this is a continuation on composite solids. In this video, we'll be looking at the surface area of subtractive solids, where, once again, we're cutting out a solid from a larger solid. As I've said before, you'll find that when we calculate the surface area of these, there's much more to consider, because unlike the volume, where we could just, for example, in this case, subtract out the volume of the center, when it comes to the surface area of this, you can see that there are actually surfaces on the inside that add to the surface of this. Okay, so let's actually get straight into it. So here we go. So for this one, I'm going to break this down. For this, I'm actually going to approach the hardest shapes first. So I'm going to call area 1 that green one here. So it's going to be the larger area subtracted by the smaller one. So area 1 is going to be, well, we have it already here. It's going to be the large rectangle, which was 10 times 8. And this is going to subtract by the smaller rectangle, which is 6 by 8. So this calculation is accounting for the highlighted green section here. But if you can imagine that there's an identical shape of this on the rear of this shape. So we're just going to immediately take all of this and double it. Okay, so that's the first one. As you can see, we can actually just easily calculate that. So I'm going to leave that until the very end. Area 2, we have this rectangle here on the right, and there's an identical one here to the left here. Let's call that area 2. And area 2 is going to be 5 by 8. And once again, there are 2 of these, so we're going to calculate that once again at the end. Area 3 is this one on the top. And that one's going to be this length here, which is 10 times 5. And once again, there's one underneath all of this. So we're going to double that as well. So that was 10 by 5 times 2. Now that we've done this, let's now consider the areas on the inside that have been exposed because we've cut out this rectangular prism on the inside of this. So area 4, I'm going to treat that as this inner surface here. Area 4, hope you can see that's going to be 8 by 5. And there's actually a second one above, so top and bottom of the inside. So area 4 is going to be 8 by 5. There's going to be 2 of those as well. And area 5 now, same idea. It's going to be on the inside, but on the left. So this one here. And on the right. And that area is going to be 6 by 5. And there's 2 of those, so we're going to double that as well. So area 5 is going to be 6 by 5 times 2. And now it's just a matter of taking all of these and taking the total surface area of all of this. So just plugging all of these, you can probably fast forward at this point. It's going to be 10 by 8 minus 6 by 8, all of this, times 2. There's the first, times 2. That gives us 64. And the remaining I can easily calculate here. It's going to be 40 times 2, which is 80. That's 40 times 2 is 80. Next one's going to be 50 times 2, which is 100. Next one, once again, is 8 by 5, which is 40 times 2, also 80. Oops. And 6 by 5, that's going to be 30 times 2 is 60. Adding all of these together, 64 plus 100 plus 100 plus 160 plus 60. All in all, this gives us a total of 384, and we said that this was in centimeters, so 384 centimeter squared this time, because this is working on the surface area, not the volume. So just by this demonstration, I hope you can see that indeed more consideration needs to be accounted for when we calculate the surface area of subtractive solids. All right, so hope to see you in the next video, and best of luck.